Welcome to the Ricci Flow Nutrition Podcast. My name is Cameron Borg. On this episode, I had the pleasure of speaking with Dr. Gary Fettke. Gary Fettke is an Australian orthopaedic surgeon with a focus on preventative medicine and nutrition. Gary has concentrated on the role of diet in the development of diabetes, obesity, and cancer. He has been speaking out on the combined role of sugar, particularly fructose, refined grains, and polyunsaturated vegetable oils in the epidemic of inflammation and modern diseases. He has incurred the wrath of Australian regulatory bodies for his stance on public health advice, but he and his wife, Belinda, actively defend the benefits of low-carbohydrate dietary patterns. Their ongoing work has uncovered the vested interests and ideologies shaping nutritional guidelines at the policy level in Australia and beyond. I had an incredible time speaking with Gary and learning from his experiences. His perspectives are clear, logical, and backed up by his decades in clinical practice. He has become a needed voice of reason within the paradoxical realm of food guidelines and public health. Gary's notions for improving public health are far from extreme and are simply based on the foundational dietary principles of reducing or eliminating consumption of processed foods, particularly refined sugars and vegetable oils. Changes such as these are the easiest to justify on the weight of scientific evidence, but the most difficult to enact due to the pernicious relationship between multinational food corporations and government agencies. Through the work of both Gary and his wife, Belinda, countless people have been able to take control of their health, hopefully having a lasting impact on the health of generations to come. With all that being said, I hope you enjoy the episode. Thanks so much for coming to speak with me today, Gary. I'd love to know, when was your first insight in your training or practice that there was something maligned about the way we practice medicine, or even the ontology of medicine, the way we treat humans for health and disease? What was your first inkling that there was something wrong in what we were doing?
I was a medical student. There's just things that didn't make sense. And I have forever challenged the system. And it always makes for an interesting discussion. In orthopaedic meetings, our x-ray meetings, someone will say black and I'll say white. I may actually agree with them, but it's actually interesting to see how people actually can form their opinions and then stand by them. And so much of what we do in medicine is actually collapses like a house of cards when you start to poke it. We can talk about drug therapies, you can talk about nutrition, you can talk about surgical procedures. It seems like a good idea. However, when you actually chase it down and you start to question on what basis did we actually come to that conclusion, then you start finding out all sorts of interesting stuff. And that's certainly what's happened with the last several years, is that most of the discussions that, we've been talking about, trying to base our decisions on science, and nutrition science is very much not that far from nonsense. It's just non-science. There's so much stuff which is opinion, and its behaviour, and what I call generational education, because we did that because our teachers told us to do that and their teachers told them. So whenever someone has an opinion which doesn't make sense, I've tended to challenge that and it's not just nutrition, but done it for decades. But what I've come to in the last 10 years is actually try and actually understand their opinion. That's fine, but how have they gotten to that opinion? And that's the fascinating bit. What bit of literature, what information has gotten them to that opinion? Because often, if they've gotten that opinion, I want to know how they've come to that understanding, because obviously their opinion's challenging my opinion. And so therefore, that's good science when you actually listen to the person who doesn't agree with you, which is fine. And that's the way science should be. It should be, I've got you've got an email from me, and on the bottom it's got science evolves by being challenged, not by being followed. So we don't have everything worked out. And clearly the whole COVID thing is a whole lot of non-science flapping around there, because the situation changes day by day, week by week, hour by hour. One country's doing this, one state's doing this, someone's doing something else. Yet, and again, we're not allowed to discuss that as medicos. I realise that's a contentious issue at this point in time. However, we're not allowed to discuss it or actually give a different opinion or a fragmented opinion, because that's, they've got APRA guidelines in place and they're being politicised. So I've been asked to get involved in that debate, not because I have an opinion as to what's right or wrong. It's just I'm in there because we should be able to question the directives and make them stand up. So it's an interesting time, but it's really just a flow on of what I've been questioning for forever. I can even remember as a 12-year-old going down to the state elections. My mother was supporting one party at the time, and I was down there as a pain in the ass 12-year-old asking the opposition parties their stand on politics. So I've probably always been a questioner.
Well, I think that's probably the best way to be, the reason
it's not at all. It's a terrible.
The reason I like talking to people is not because I think that they're right. It's because I want to hear what they think. And, probably 99% of the ideas you hear are going to be wrong. But I think if you can figure out precisely where they're wrong, you've just taken a giant step forward. So I think questioning as much as possible, and particularly being able to ask questions without being hindered, is something that should be valued more in science.
Well, it's theoretically that's what science is. That's the scientific method. You've got a hypothesis, you've got a belief. You are supposed to disprove the belief. But there's a talk on mine on YouTube called "The Failure of Medical Education," and I delve into that because I think medicine and nutrition is all about, if you do the courses nowadays, it's about read, repeat, reward. I use those things. If you read the textbook and you repeat it in the exam, and then you get rewarded. You pass, you don't get into any trouble, you get remunerated quite well, particularly here in Australia. And life is simple. And I have said to my medical students over the years that I'm still employed, as a doctor by questioning. But the road at times has been somewhat rocky when you challenge those paradigms and you find out. And nobody likes to be challenged on their beliefs. But I think it's okay to challenge people on their beliefs when I think they're causing patient harm. And that's really where the whole nutrition thing unfolded for me. But, 30 years ago, I wouldn't operate on smokers, for elective major surgery. And, there was enough literature around at that time if you looked for it. There was a talk I gave which is called "Where There's Smoke, There's Fire." But you had to go looking for it, but there was information there that's saying that smokers actually do poorly with surgical outcomes and major. Now, 35 years ago, that was a really right-wing concept. However, nowadays, that's perfectly accepted by the majority of the population, that smokers have a poor outcome in elective surgery, cardiac surgery. That goes on, plastic surgery. Everyone's advised not to smoke before anaesthetics. But I can tell you 35 years ago when I started talking about that, I was just waiting to get sued because it was such a radical idea. And 12 years ago when I started talking about sugar and the perils of it, everyone looked at me as though I'm completely aghast. So I'm delighted to see that the concepts of too much sugar being troublesome for us, and has actually gotten, that's in the headspace of most people now. So but it's interesting that it's occurred in such a quick time frame.
Yeah, absolutely. I guess if we think about what we're currently being taught, I went through 3 years of tertiary education on nutrition and learnt essentially nothing about nutrition. So if this is the framework that we're in at the moment, what do you see as the major the things that are wrong with the current framework in medicine and particularly in nutrition?
Well, I think it's one thing to say it's wrong, but I think where I'm coming from is to understand where our textbooks have been written. And this is some of my work, some of my, particularly my wife's work, Belinda. And because she said, you guys are going blue in the face talking about the science, and she started looking at the vested interests. And when you start looking at that, you find out that our textbooks have been written by industry for over 100 years. So there's a thing called the Flexner Report, which was commissioned by Carnegie and Rockefeller. So Carnegie of steel and Rockefeller of oil. And they commissioned that in 1910. And with that, they closed, I think it was 54 medical schools in the US and Canada, and actually got rid of holistic healthcare, or phased it out, and introduced the pharmaceutical industry. And then they sponsored universities and university medical schools for decades, as long as they were doing research that actually suited that concept of what read, repeat, reward, and to medicate and to operate. Preventative health is just, there's no money in preventative health. And so therefore, when you go back in time, you find out our textbooks, my medical textbooks, have effectively been written by the pharmaceutical industry since 1917. And I think it was sort of 2020, 2019, Harrison's, which is our major textbook of medicine, the authors of it, the editors, had received $12 million from pharmaceutical industry. So it's if you the most critical textbook, which is referred to in medicine, Harrison's, you've just got to question the vested interests on it. And then with nutrition, it all comes back to October 22, 1917, with the formation of the American Dietetics Association. And that was a historical moment where they came together and they formed that, and they started writing the textbooks for nutrition and dietetics for the world. The only problem was, in retrospect, the person who started that was a woman by the name of Leonard Cooper. She then wrote the textbooks for the next 40 years, which became the textbooks right around, and became the model for the UK, Australia, South Africa, New Zealand, and Canada. The problem with Leonard Cooper, undeclared, but you go back in retrospect, is that she was a Seventh-day Adventist working for John Harvey Kellogg and was completely under the influence of the vegetarian, vegan cereals and grains. And you can go back to their textbooks, and we've actually gotten hold of a couple of those books, not from the 1917s, but 1921, and they're essentially a vegan cookbook and a vegan textbook. And you can go into the textbooks nowadays for dietetics and you start looking up words like protein. You find protein in there, but you rarely find the terms of meat. We had a place called Nutrition for Life for some years where we tried to help patients find good advice. We had dietitians, diabetes educators, all on board. And one day I said to them, can I have a look at your textbooks to the dietitians? These are your textbooks, which are part of the current curriculum. And I looked up meat. Just wanted to find the word meat. Anyway, there were 3 references in there. This 800-page book to meat. One was mad cow disease. Another one was food poisoning. And the third one was under potential sources of protein in the protein chapter, but it was only in a table. And we said to the team, I said, okay, how much do you know about meat from your textbooks? And they said, we know a lot about meat. And I said, no, go. And said, don't let me just read it. Go home now. I want everyone to actually go to their textbooks and find out how much education you had as a dietitian and in nutrition about the benefits or the harms of meat. It wasn't there. The 2013 dietary guidelines, which I think if you had James Mookie on there, James has been instrumental in trying to get hold of getting that reviewed. When you look at that document, and James and I have been working together on it with Belinda, when they looked at the food categories, there were only 2 questions that were out of sync. They had 2 specific questions they wanted answered. And one was, what are the benefits of cereal and grain? And what are the harmful effects of red meat consumption? Now, that's a loaded questions before you even start your research. Every other category had what are the harms and benefits of different foods, which is what you want, isn't it? You want, what are the harms and benefits of salt, and what are the harms and benefits of fibre? You can go down every one of those topics, and fruit and vegetables. But that question, completely loaded, was what are the detrimental effects of red meat consumption, and what are the beneficial effects of cereal and grain? Now that then becomes, and everyone goes, oh, they're only the dietary guidelines. But then I used to be eating by the dietary guidelines, and I was 20 kilos heavier than I am now. I was fatter, I was sicker, I had high blood pressure, I was pre-diabetic. I had my tumour issues, and I was metabolically unwell. And I was eating by the dietary guidelines. Sure, I used to sneak in a bit of chocolate, but I was doing the right thing. And the dietary guidelines form the advice that is given out by doctors. It forms the advice that hospitals feed their patients, nursing homes feed their clients, schools feed their children, the defence forces feed their troops, and the prisons feed the inmates. Whenever you look at world data on armed forces, they're getting obese. These are our elite soldiers to help look after us, and obesity is a major increasing problem within the defence forces, not just here, but also in the US. And the US have published quite a bit of data on that, all following the guidelines.
Yeah, you deal quite a bit, correct me if I'm wrong, but with diabetic patients who are fairly advanced and may need some sort of amputation. I was wondering if you could go into what you see as the main problems in the pathophysiology of diabetes, and particularly how it gets to that end stage where you're getting blindness, you're getting diabetic ulcers on the lower parts of the legs and feet. What's going on biochemically that's causing all of this to happen?
Well, just to clarify, I'm taking a bit of extended leave for a couple of reasons at the moment, but so I'm not actually treating anyone with diabetic feet problems. And part of the politics of my life is I'm not working in the public hospital system, which is where most of my experience was. So for well on 2 decades, or a bit more than that, I was looking after most of the diabetic foot complications in northern Tasmania. And that was just, we call it, it was a Friday afternoon, and I used to call it Fettke's effed up fructose-free fungating foot folly Fridays. But I don't quite know what the effed up stands for. And every week, my operating list would have planned for elective surgery on the Tuesday. And I can remember, but by Friday it had changed because there was someone requiring some acute management. And most of those were acute trauma or infections that just had to be done. And I can remember, come back a few years now, but I did, I think, 6 elective operations in a 12-month period. So every Friday was effed up because we were just, everything that had been planned 3 days beforehand went out the window by Friday. And a lot of that was diabetic foot complications. And so, I don't know, you just have one of those moments when you go, hang on, enough's enough. Because it used to be, an occasional thing, and then all of a sudden it became all-consuming, and then a lot of the patients just ended up referred there because nobody would else, it's not much fun looking after patients with diabetic foot problems. You have to see them all, regularly, every week or two, contact casts, debridements. How's your ulcer? Well, it hasn't changed much, and it's not particularly rewarding, and it's smelly. It was smelly. And then one day it dawned on me when I went and saw one of my patients as an inpatient, his foot out of control infection, and he's got poorly controlled glucoses, and he was eating ice cream in the hospital as an inpatient. And I said, hang on, what the hell's happening here? Why are you eating ice cream? He said, I like it. Well, I said, well, this is just bad for your blood glucose. And he said, I have it 3 times a day. And so the hospital, and I said, hang on, this is where did this come? So then I started looking into it in the hospital food. And the hospital food, if you've got diabetes, allows and arguably recommends 3 desserts per day, sugar-fueled foods, and snacks which are carbohydrate laden. And I suppose that's when the penny dropped for me about, and I know it's so flaming obvious to think about it, stop feeding people with out-of-control diabetes excess sugar. I then started to say, hang on, we've got to do something about this. And I was told, no, you've got to change the guidelines. And once I started questioning the system and questioning the expert advice that was coming from dietitians, well, then the war started. And it literally, and around about that time, I started looking into sugar. I started looking at the metabolism of fructose, which was very little known. Most people are not aware that it wasn't until 2010 that a fellow by Look Tappy, is a Swiss fellow who I have met, defined the definitive description of fructose metabolism. So we know a lot about glucose metabolism. Sugar is glucose and fructose. And we've known quite a bit about glucose. However, there's got a heap of new stuff about glucose just in the last couple of years, and particularly in tying in with insulin, diabetes, orthopaedics, and vascular disease. I mean, we can go down that path in a sec. But he described the metabolism of fructose in 2010, and I went, wow, this just makes sense. All this, all these pennies started dropping, And when I start looking at fructose and then the effects of that on the liver and the kidneys and on our eating habits and how it changes and drives behaviour. And then I started looking at glucose, and then I found out that when, if you're insulin resistant or if you're overweight or diabetes, you get 30% of the glucose that you eat gets turned into fructose. And I went, wow, hang on, this is runaway train stuff. And then I came up with a nutritional model in 2014, something like that, nutritional model of modern disease, which was the combination of excess carbohydrate, fructose, and polyunsaturated seed oils becomes an inflammatory mass. And that gets inserted into our cell membranes, our mitochondrial membranes, and potentially is the source of a lot of disease. As it turns out, that model is probably close to the mark. Again, it's just a hypothesis. But I got onto social media because Belinda and one of our daughters said, hey, Dad, this is really important stuff. You're making a difference in the hospital. You should tell people. Within 24 hours of going public and into the world of the internet, I was being chased down by someone who was working for Coca-Cola. And then ultimately, as time's gone on, I became the target of the cereal industry. And we've got these documents that have been presented to Senate inquiries where they're saying that cereal sales are down in Australia. This is from the Australian Breakfast Cereal Manufacturing Forum, since dissolved, but the heads of the CEOs of these major corporates in Australia sit down and have lunch together every few months in Concord Golf Club. And the minutes of those meetings came to us, and they said cereal sales are down in Australia because of the concepts of low carb and paleo. And these 7 people need to be targeted, and obviously only Australian doctor on that list. It took some years to uncover after I'd been reported to APRA and gone through a whole lot of stuff. And that's essentially where Belinda's work came, because I've learned all this biochemistry because it made sense, but then I had to defend my situation, had to defend my medical degree and my registration. And so essentially I've done a thesis, a doctorate on nutrition, metabolism and biochemistry because I had to defend myself. And after about 3 years, ultimately they found against me that doctors and the surgeon, I'm not allowed to advise my patients to reduce sugar. That's literally what the medical board came down with. Thank goodness for social media, because we announced that and Belinda put a post up which had over 1 million viewings, because it just doesn't make sense. That's like doctors not being allowed to tell patients to stop smoking. With what we know about the perils of sugar, And then it took another 2 years, 3 Senate inquiries, the National Ombudsman, and ultimately I was cleared. Some of your viewers probably know about Tim Noakes in South Africa. And Tim was going through exactly the same situation in Cape Town. His court case was an open court case. Mine was behind closed doors. And I got to present so little of that biochemistry, but I presented it, but it was just ignored. So the more time's gone on, we realise this is not about biochemistry. This isn't about health. This is about politics, and this is about profits. And again, so therefore, if it's not about science and it's not about making people better, how on earth did we get to these conclusions? How on earth did we understand? How did our guidelines get to be so corrupted, to be so full of processed food? And you look at the Healthy Guide to Australian Eating, it's shocking. And it's even worse if you look at the one for the Indigenous community, where it's actually got, and it's not branded, but it's got the image of a Coca-Cola bottle on it. And it's got an image which is consistent with Weet-Bix. And 40% of Australians are illiterate. So if you've got a visual image, you won't need to read the writing on it. It's and the whole thing about health is health information. And you sort of asked me how we got to this point. I actually think it's disinformation. And we've got a tragic level of literacy of 40% in the community. We've then got the major pharmaceutical food industry giants controlling our education, controlling the information that's going out. And it's not about health, it's about profit. And so when you delve into the biochemistry and you go, hang on, this just makes sense. Finally, I understand now why my health had deteriorated and why most of my patients' health had deteriorated, and why those people, particularly with diabetes, deteriorates with excessive carbohydrate consumption. So diabetes, I think you want to talk about the biochemistry of that to a degree. There's a talk I've just done in the last few months on carbohydrate, the dose is the poison, where I thought, okay, we understand, there's this demonisation of carbs, and I'm part of that low carb community and low carb keto community. Let's take the argument and say, okay, how much dose is actually considered toxic? Which is, that's the argument really, if something's toxic, how much do you need for it to become toxic? Because we're all told that you've got to have your glucose, you've got to have your carbs according to guidelines. So therefore, my definition of toxicity is when it has a negative impact on the system. So the moment something has a negative impact on the system, and your viewers might see this as a controversial statement, but I found out that the biochemistry supports the argument that it's 1 teaspoon of sugar, of glucose, has a negative effect on the system. Fructose has a negative effect if you say it drives behaviour towards eating, and ultimately it has an effect on our liver and kidneys and our lipid profile. And it's really, to go through, it's probably worthwhile people having a look at that talk so we don't have to dwell on it right at this moment. But if the 2 salient features about glucose is, one, it has a direct effect on the glycocalyx, and it has a secondary effect on insulin. So the moment you eat glucose, your body produces insulin to store it. Now, I make the argument in that talk is that the body actually hates having glucose in the bloodstream. It hates it so much that it does everything it can possibly do to get it out of the bloodstream as quickly as possible. That's called maintaining our blood glucose at around 4 to 5. 4 to 5 is around about 1 teaspoon of glucose in the bloodstream. So the moment you have in excess of 4 grams of glucose floating around in the bloodstream, your body does everything it can to get rid of it. And it does that via insulin. That's the simple thing. Insulin has it stores glucose as fat. It is a growth hormone effect on tumours, and it has an inflammatory effect on the body and particularly our joints. That work came out of China in 2020. Great papers. And I've talked about that before because I think they missed the point. They showed a dose-dependent effect between glucose consumption and inflammation and insulin production. And at the end of it, they said, we need to target insulin as a method of treating osteoarthritis. I went, hang on, you've missed it. If you actually don't eat glucose, you don't produce insulin. So it wasn't written by a low carber trying to bang their own drum. It was literally they found insulin as an inflammatory hormone on top of it being a fat storage hormone and a growth hormone. Coming back to the glycocalyx, the glycocalyx is arguably the largest organ in the body. Most people think it's the skin, but it's actually the glycocalyx. It's the surface area of our blood vessels. And the glycocalyx is like tiny little fingers, which we've got in our airways to clear things, but they essentially just push the blood cells along in the bloodstream. It's arguably about the size of a football field, the amount of surface area in our bodies. I think it's actually a bit bigger than that, but I'll just say that. So the surface area is, and it's under the direct effect of glucose and nitric oxide. So nitric oxide, which is something which is produced, there's three forms of it. One which is an endothelial one, which is actually maintains our blood pressure. There's one that's actually a neuronal one, which maintains our blood supply to our brain. And there's actually another one which is related to actually maintaining how our white cells move through into the tissues. But for the argument of the glycocalyx, is that the surface of the glycocalyx will secrete nitric oxide. Nitric oxide is an incredibly effective vasodilator. So it literally opens the blood vessel up in front of it. It's only got a half-life of a millisecond. But however, our glycocalyx, literally as the blood cell comes down along it, down that tube, we're not talking about the aorta, we're talking about the tiny little arterioles. It'll come down and the glycocalyx secretes nitric oxide, which opens up the blood vessel in front of it. And then under that effect, the blood vessel, so it's literally pumping the blood along. So the glycocalyx actually smooths out our blood vessels on the inside and is involved in nitric oxide production to actually to spit that blood vessels, the blood components down the blood vessel. What's interesting, a dose of glucose, and particularly elevated glucose, and particularly if they're up over a period of time, will harm that glycocalyx within minutes. And it's harmed for several hours, and then it will regrow. So if you've got diabetes where your blood glucose is elevated chronically, then your glycocalyx is, on average, half the thickness that it should be. Therefore, it's half the nitric oxide. It's also it's affecting the blood supply and it's affecting the flow. And the smaller the vessels, the more harm it is. So therefore, you've got poor nitric compounded by fructose. One of the byproducts of fructose is nitric oxidase. And nitric oxidase, one of the byproducts of fructose is uric acid. And uric acid inhibits nitric oxidase. So nitric oxidase is the thing which actually releases the nitric oxide in the villi, in the glycocalyx. So if you have fructose on top of that, then its byproduct is uric acid. Uric acid affects the nitric oxide. So your glycocalyx is halved, let's say, for argument's sake, and then it's trying to actually produce nitric oxide to improve flow. But if that person's also had a fructose load, which is the half of sugar, then it's actually being harmed as well. So that combination, just at a glycocalyx level, which is a flow issue, and particularly the smaller vessels and the most important ones, will actually slow blood supply down to the periphery and slow the blood supply down to the eyes. And then it actually increases the arterial tension, so that actually pushes up the blood pressure. So we've actually got, and apart from the fact that also once you affect nitric oxide by uric acid, you would decrease immunity, and how white cells actually get and migrate through those poorly functioning vessels to get to the zones of injury. It's just quite fascinating. I mean, I didn't know this. And I just thought that it was a bad idea to give my patients with out-of-control diabetes 3 ice creams a day. And so I've been on this journey to learn a lot more. But all this stuff is not in your textbook. It's not in my textbooks. And even fructose metabolism just creeps into the current textbooks. But it's all there. And thank goodness for the internet, because that's how I found out about this stuff. And then there are papers there, and you've got to research it. But it's a matter of communicating with other people who are like-minded. And have you seen that? I can remember reading that Dick Johnson is a nephrologist from the US, and he has a book. He's got a couple of books out. Fabulous, lovely guy, and he published this stuff about uric acid. Not about he's writing uric acid, but the polyol pathway, which is the conversion of glucose to fructose. And it was just one of those moments. You go, I get it. Now I understand the runaway train of our health disaster. It's not. And I've caught up with Luke Tappy, who was actually sponsored to come out to Australia by Coca-Cola to talk about that fructose by itself is not the cause of obesity, which is quite right. Fructose by itself is not the cause of obesity. But I listened to his talks, I caught up with him, and he talked about all the side effects of fructose, the liver effects it has, it talked the renal effects of it, the LDL production. He talked about all the side effects of it, but it wasn't just the cause of obesity. But I travelled to that meeting in Sydney to actually ask him one question. And I said, and I caught up with him lunch, and I was going to ask him that. I said, I'm going to ask you this question after lunch. It was interesting. It was an ILSI meeting, which is the International Life Sciences Institute. It's their scientific arm of the food industry to say that everything's fine, and it's not. But Coca-Cola was a founding member of it. Anyway, I stood up there at the end at the meeting. I said, Professor Tappy, I'd just like to ask you one question. I said, is there a human biochemical requirement for us to eat fructose? I knew his answer beforehand. He said, no, Dr. Fettke. But when I asked that question, when I actually stood up at the Coca-Cola meeting, I'll sort of call it that, when I turned around and said, it's Dr. Gary Fettke from Tasmania, then the entire audience turned around. So I knew that I'd probably been on the right pathway for the last several years as an anti-sugar campaigner, walking into the lion's den. But that was a bit of fun that day. So therefore, we don't need to eat fructose. Don't take my word from it. Take Luke Tappy's, who's the guy who described the metabolism of fructose. A very tiny amount. We produce a small amount ourselves in the mesentery of the gut, and we also in the seminal vesicles, which is interesting about the mesentery of the gut, because elite athletes, particularly endurance, actually do take honey supplements. There's a bit of work on fructose supplements, and theoretically it shouldn't have any effect, any benefit, but fructose under extreme stress is metabolized a small amount in the mesentery of the gut. The rest of it gets done in the liver. So I think and that's possibly the only role I can see, that's the biochemical link in there in elite sport, and having some honey supplements, halfway through it. I don't know how effective it is. You probably need to speak to Paul Mason could answer that one. I'll have to have a chat with him one day. But we're just bouncing topics around here at the moment. So look, if we just purely look at the glycocalyx and we look at insulin, then all you need is above 4 grams of glucose to start having a negative effect. So that goes against dietary guidelines.
Yeah, absolutely. I think one thing I wanted to get a little bit more into before I ask you a little bit more about uric acid, because I really want to ask you about gout today, but I want to make the distinction between the sugar that you're talking about, which most people are consuming, and things like starches. I wanted your opinion on whether you think the role of starches, these are things, like whole grains, yucca, taro, yams, sweet potatoes. These have been around for tens of thousands of years, and we seem to have utilized these starches fairly well. Do you see a place for these types of starches in at least some individuals? I know there's a seasonal and longitude and latitude component to this, but broad strokes, do you think there's a role for these starches?
Is there a biochemical requirement? No. All right. So therefore, we can get by without them. Okay. Right. So if we look at an evolutionary aspect, there were entire seasons where we couldn't get it by without starches because they are a seasonal crop. I'm trying to find the references to it. I go back in time and say apparently we can track osteoarthritis by the migration of the potato. So the potato came out of South America, so it's not an indigenous crop around the world. It certainly shouldn't be a seed. It shouldn't be available 365 days of the year. It's a bit like fruit. I talk about that. I understand it's controversial, but nonetheless, if you come back down to the biochemistry, we don't need glucose. Our body, when it comes across glucose and fructose, is wired, evolutionary-wise, to actually get as much of it into the system so it can get fat for winter hibernation. So the majority of starches, complex carbohydrates, so they're only glucose or fructose or combinations thereof, and the moment you put a complex carbohydrate into your mouth, the amylase will start dissolving it into sugar. You can do that with a piece of bread. You just hold it in your mouth there. It gets all soggy, but very quickly it's sweet. And so the fruits, the complex carbohydrates, are seasonally available, and when we come across them in nature, then we are wired to eat as much of it as we possibly can. And the fructose metabolism via its pathways on the hypothalamus and the nucleus accumbens make us quite addicted to it. It's fascinating, and it also has a ghrelin effect, which makes your tummy hungry. An anti-leptin effect, so that dampening effect of being too fat. When you get too much fat on board the body secretes a hormone called leptin that affects the hypothalamus and tells you don't need to eat anymore. But fructose has a direct inhibitory effect on that leptin effect on the hypothalamus. It's just sugar makes you hungry. Carbs make you fat. Polyunsaturated oils make you inflamed and sick. I think that was my meme at some point in time. And I recognise that simplifying it down, but that's probably it. So if we've got a belief that, and yes, the entire cultures will have a supply of yams in their lives and sweet potato. And if that's a traditional food and it's seasonally available, sure, that's part of the way. I might argue with it may not be tens of thousands of years, it may only be 10,000 years before we started apparently farming and cropping. We're far more nomadic. Part of that nomadic lifestyle would have been to go and dig up stuff as you in between hunting down for other foodstuffs, predominantly animal proteins. So I'm fascinated by the evolutionary aspect of it, because if it wasn't available, how did we survive? And there's always exceptions to the rule, but in principle, we've needed to survive with our nous, and that's actually been to hunt, and we're designed for hunting. We are. I don't know if you've seen any of that work on persistence hunting.
Yeah.
Just fascinating that we have the ability to sweat, we're ability to fast. We can actually keep going for miles and miles and actually just push an animal till we're not faster than the majority of wild animals, but we have the ability to keep moving them along till they just collapse under exhaustion. and then when they collapse, then you can go down and club them. That's probably how we did it. I've had there's a fellow in the US he still teaches persistence hunting. I've forgotten his name. I've got an open invitation to come and visit with him, and he'll take me out on a persistence hunt, and then hunt the animal, but acknowledge that the animal's place and to eat tip to tail. I think and that's when I think we're missing that in the whole animal versus plant nutrition debate, is that an animal eaten tip to tail is nutritionally complete. It's got everything we can possibly require without the excessive carbohydrates, which are the things which I think so much of our obesity problems is people chasing nutrients, which they don't find in their day-to-day food. So if you don't have a complete nutrient profile that hits you over a period of a week or so, right, you don't need every single micronutrient every day, because we've got backup supplies of a lot of them. But if you don't get your micronutrient balance right over a few weeks, then you're constantly chasing more food, thinking, I use the example of a pizza. Pizza's got lots of colours on it, heaps of carbohydrate on the base. I'm the guy who eats all the pizza topping, by the way. If one comes out, I'll eat the topping, but not the base. So you eat all this eat all this stuff, but it's micronutrient deficient. So what do? You eat another pizza, and you eat another one. All of a sudden, you're still missing your micronutrients, but you've eaten truckloads of carbohydrate, truckloads of energy that you don't actually need. The body produces an enormous amount of insulin to store that as fat. Over a period of time, you become insulin resistant, you get fatty liver, then you get all the other sequelae, which you talk about with being metabolically unwell, the whole metabolic syndrome. Once you've seen it, you can't unsee it. Okay, you're eating that and you're going to be hungry in a few hours' time, looking for more food. The classic is a Chinese meal. You go out and have Chinese, and they put a lot of sugar in that to cover the other spices. And part of that's so you're going to order more. I'm not stupid. I mean, it's like Chinese food in China. I haven't been there, but I've been in other parts of Asia. Is nowhere near as sweet as it is in Australia. And we've all been on that journey where you actually go and have your Chinese meal, and then on the way home, particularly in my university days, you're finding a kebab on the way home because you're hungry. And then if you've been on the Terps, and I can remember that, then you come home and you look for ice cream. And if you've had a really bad night, then you're trying to eat ice cream with a fork. That's these are pre-Belinda days. Okay.
Sometimes if I want to have a big meal at night and I've just had lunch, I'll make sure to have some honey or some chocolate. Because I think it'll make me even hungrier. I'm not sure if that works, but sometimes I like to have big meals.
Well, it's quite interesting. Occasionally over the years, and the last 10 years, some sugar has snuck into my meal. And I used to be a chocolate addict, family block a day. I wouldn't take plasters off unless you brought me a chocolate cake, and I was a complete chocolate and sugar addict. But now I've been off it for so many years. And I can remember having a Thai soup, which actually had a whole lot of sugar in it. I didn't pick it. And a few times this has happened, I lie awake with the most vivid nightmares that night. Just amazing. And I'll wake up and go, I think I've had sugar. I don't know where it's come in, but I think I've had it. And the same thing goes, and I'll be hungry for the next 12, 24 hours. I just go, whoa, I'm so hungry. But now I understand the biochemistry. I go, okay, that's all right. So, people say, do I eat fruit? And I say, yes, I do eat some fruit. But if I do, I'll have some berries, which are generally in season. And I'll have 3 or 4 of them, and I'll have them at night with some double cream, and Belinda makes a granola up. And so therefore, if that's going to make me hungry, it's going to make me hungry when I'm asleep. So I'm biohacking, like if I'm going to have that, because fruit in the wild is designed to make you hungry. That's why a possum will strip a tree bare in a night, 2 days before the fruit ripens for humans to eat. It literally, a possum cannot possibly eat that amount of food unless it's something driving the biochemistry. I use the example of a Brazilian barbecue. Have you been to a Brazilian barbecue? Like have as much meat as you want, animal-based protein. Just literally, you just have to stop. You just can't get through it.
Have you spoken with David Rubenheimer?
I know of David, but I haven't spoken to him.
Oh, right. What you're saying just reminds me very much of his work with nutritional geometry, where we're striving for an amino acid target and we'll eat as much as we need to reach that target. So, and I think his work is awesome. And I think I'm trying to get him on the podcast. But yeah, I think what you're speaking to is exactly that point, that somewhere in the brain, we've got these pathways to make sure we eat to a certain level, and in nature that would provide us what we need. But we're far from the Garden of Eden.
Do you know Marty Kendall?
No, I don't.
So Marty's entered this nutritional field because his wife's got diabetes. It's very obvious, type 1, and he's gone down the low carb. He's another engineer in this field who's actually just looked at the data.
Mm-hmm.
And Marty, well and truly worth looking him up. He's up in Queensland, I think. So you should get him on and have a chat, because he talks about the entire nutritional profile, and he actually does that as a whole metabolic investigation now. And he's got a nutritional, and again, in the early days, I said, Marty, this is what we need. We don't need, the standard apps tell you how much sugar you've had, how much protein, how much fat, gives you some, kilojoule equivalent, which means we start counting calories, and heaven forbid that's just a nightmare again, because everyone thinks that counting calories is going to lose weight. Well, you're not going to count. That doesn't work if you're constantly hungry, and it doesn't work if you're micronutrient deficient. So he's been working very hard on this modelling and come a long way with it in the last 5 years to actually look at what your overall micronutrient profile is over that whole 1 week, 2 week, 3 week, 4 week period. And I think that's called balanced eating. And then probably add that in, that's over a 12-month period when you take into account seasonal availability. And as a human society, we've drifted so far away from our evolutionary diet. It doesn't matter where you are. I talk about, I've rewritten the dietary guidelines, in a brave moment. I don't know if you've seen that, where I've said, eat fresh, local, seasonal, whole food based on your culture and environment, avoiding added sugar and processed food. Whoops, one sentence. It's actually gone to the NHMRC. Apparently, James tells me that they thought it was too simple. I said, no, I think the budget, I don't know, is $10 million. I said, give me 8 and I'll rewrite it with nice font. And because everything, dietary guidelines, it just get reinterpreted in so many different ways. Whereas what I've just done in one sentence, I've actually described a low-carb, healthy fat, relatively animal-based diet in that one sentence. But that's the way we evolved. We evolved by, and we got to the top of the food chain by eating fresh, local, seasonal, whole food. I talk about fructose and latitude because that's, I think, important because of the role of vitamin D in the equation, in the metabolism of the byproducts of fructose. And but in Tasmania, we're incredibly fortunate that I can actually get fresh, local, seasonal, whole food. And that's and a lot of places around the world can't get that, particularly with lockdown. You couldn't get fresh, local, seasonal food, but your alcohol outlets were all delivering to the home. That's completely insane.
I want to touch on this locality idea a little bit more. You've spoken about the fats that we eat and how they end up in the membrane and the cell membrane and impact membrane fluidity.
And
you've
the
also,
mitochondrial membrane. I think that's
yes.
another side of it. Yep.
And you've also spoken about eating seasonally, which in my eyes speaks to this idea that our intakes of different types of fats will change throughout the year. And if the fats we eat throughout the year are going to be different depending on what season it is, then the membranes of the cells in the mitochondria will also change throughout the year. I haven't been able to find any information on what role, maybe more, what role would more or less membrane fluidity play seasonally in keeping you healthy?
I'm just trying to think of his name. He's in New York. He'll come to me, and I came across his seminal work on fats and oils. He's actually written a book called Fats and Oils. And he wrote this article when I was really looking at the whole role of polyunsaturated oils in our inflammatory milieu. And I found the article and then I wrote to him. And he said, "Oh, Dr. Fettke, you've got some good questions. I think you'll find the answers in my book." So I bought his book, read it from cover to cover. Let's say it's a fairly dry topic, human fats and oils. And and I wrote back to him at the end and said, "Fascinating read, but you haven't answered my question, which is what is the half-life of linoleic acid, which is one of the omega-6, it's the pro-inflammatory one, which is this roundabout way to answering your question without giving you an answer." Because I said, I can't find that out. So if we're taking in inflammatory fats into our body, which is one of those arguments, and linoleic acid possibly is the one which is related to a lot of inflammation as an omega-6. And he said, "I don't know. But it could be 4 years." So it appears that the fats that we ingest are part of our body for a few months to a few years. And so therefore, that would tend to counter-argument your seasonality, fluidity aspect. I'm not disagreeing with you, but I'm trying to work out what's the half-life of fats in our body. And the one which has been looked at the most, as far as I'm aware, is linoleic acid. And it's somewhere between a few months and his first name starts with G. It's coming there. I refer to him in some of the talks. I've got a mental blank. So I'll send you the link when I find it. Okay.
Great. Yeah, I'm just.
And so therefore it's 4 years. And I use the example. I tell the story because I think it's interesting because those people who get rid of the inflammatory fats out of it, so you can improve your diabetes control overnight, immediately, within hours, if you stop excessive glucose intake. You can improve your nitric oxide effect immediately if you stop eating fructose. But if it takes 4 years to get the inflammatory oils out of your body, then it's going to take 4 years. That's the half-life of fat. And I have two examples. One is my sister-in-law, and I'm allowed to tell the story, where she's got diagnosed as MS, multiple sclerosis. It's a slightly odd picture, but nonetheless, she finally listened to me and dropped the polyunsaturated seed oils almost 4 years to the day. She said, all my symptoms have gone. Now that's anecdotal. It's not, but when as I ask people in the low carb community, that keto community over time, I said, "Tell me what happened. How do you feel?" And lots of people feel different, and improved health pretty well straight away because they're improving their metabolic syndrome. But there's another group that actually tell they kept improving for a few years. And to put a lighthearted moment on, our daughter, not our youngest, we're at the airport, and at that point in time, she was addicted to McDonald's chips. I realise it's a free plug for McDonald's chips, but nonetheless, she was addicted to them when you came off a plane. That, "Can I have some McDonald's chips, Dad?" Because I cook in seed oil. And she said, looked me straight in the eye and said, Dad, as a 16-year-old daughter, she looked me in the eye and said, Dad, I promise not to get pregnant for 4 years. So what father is ever going to knock back a comment from their 16-year-old gorgeous daughter to say she's not going to get pregnant as a teenager? So I said, good argument, informed decision, here's the money, buy some chips. It's a bit like smokers. I mean, smokers who want to smoke nowadays, they're making an informed decision to be an idiot. That's okay. There's so much information out there about smoking being bad for you. There's starting to be information about sugar being harmful for you. There's some information about the seed oils being harmful to you, but there's so much disinformation, I call it deliberate misinformation by the food industry, that the classic thing is the cereals and the grains, and the whole fibre argument. I mean, I think we've got the cereal industry on sugar. We've got them on carbs. So their last bastion of defence is fibre. And David Gillespie, not the author, but David Gillespie, who was the Assistant Minister of Health, 2 years ago came out with a public health statement saying we need to increase our fibre intake by cereals. Who wrote that? That press release was written by Kellogg's. So we've got our gut federal parliamentarians reading out press releases written by the corporate food industry. And I know it's a controversial topic, but fibre, again, when you start breaking it down, literally, or you can't break it down, insoluble fibre, we don't have a huge biochemical necessity for it. And therefore, when you start saying, well, if we actually don't need we don't need it from a biochemical point of view, and evolutionary-wise, we had small amounts of fibre in our diet, why on earth did we end up with a food pyramid that had 6 to 11 servings of cereal and grain at the base of it? And that's when you start going back and you find out, okay, well, John Harvey Kellogg designed breakfast cereal to actually quell our lustful thoughts and stop us from masturbating. I know that's a huge topic in itself, but food was designed by Kellogg's and subsequent industries, and bearing in mind that most of the cereal industries of the world started in a place called Battle Creek, Michigan, around the turn of the last century. And around that 1900 period, 101 cereal companies were developed there. But they were virtually all started by the Seventh-day Adventist Church and its members. And then Ellen G. White, who was the prophetess of the Seventh-day Adventist Church, actually came to Australia and started a company called Sanitarium, but started up that was owned by the church so they could actually continue to actually make money and don't pay taxes here in Australia. But the whole Sanitarium Health and Wellbeing is owned by a church entity, which is a vegan organisation producing cereals, grains, up-and-go, highly processed foods, and been involved in writing the dietary guidelines for 100 years, telling us about the benefits of cereal and fibre. So fibre was there all to just get your bowels going. I'm not saying getting your bowels going isn't a bad thing, but nonetheless, it was designed. It was a designer food, breakfast cereal, which was there to get your ablutions going and to quell your lustful thoughts. So it's not science. But it's ended up becoming part of the fact that our Deputy Minister of Health says, bravo, we've got to have plenty of fibre, so it's good for our constitution. It's not based on good science, though. And that's why I find it's fascinating when everyone, again, going back to the dietitians, I said to them, we used to have meetings all the time just where we talked about topics and science. I said, tell me about the benefits of fibre. 4 dietitians, okay? I said, tell me about the benefits of fibre. They said, oh, it's good for you. I said, no, tell me how it's good for me. Just tell me what's actually happening biochemically, where it's happening, what's happening. And they, all 4 of them, smart women, all looked at me with blank looks, all looked at each other with blank looks and went, oh, we don't know. We're telling everyone this, but we don't know. And then there's a great talk by Paul Mason on fibre. I was giving my diabetes talk when Paul was giving his fibre talk, and we were sitting next door to each other. And I said, and Paul, I just say to people, go along and look at Paul Mason's talk on fibre. I mean, it was the talk I wanted to give, but he gave it before me, and he's done it better than me. So it's just a nice summary of the lack of biochemical, the lack of science behind it. It's just fascinating. When again, most of these topics, you touch on them, they just fall over, and you just find out that it's just so much of it's just made up.
Yeah, look, I think there's very few people who are really, thinking about these things who would disagree with what you're saying. And I think a lot of people would have seen Paul Mason's talk on fiber. It's become something of a meme going around, and I really think we're yet to understand the role of fiber in the gut, because I don't think we understand the gut very well just yet. But
I think it's part of our evolution, but it mimics the food that we eat. And if you actually have a wide variety of seasonal food that comes into your gut, you're going to end up with a fabulous gut microbiome, which is going to be involved in digestion and creating the lower gut, organising some of those micronutrients that we require. But the sanitized, highly processed food, seed oil, chemically enhanced, antibiotic-laden food that we have that's hitting our guts at this point in time is wrecking our microbiome. But to believe that fibre is going to get you out of trouble there, well, there's Australian expletives we can use to describe it. It just doesn't make sense. So if it doesn't make sense, how do people come to that belief? Okay, how do they come to belief? Well, it's actually based on religious ideology, and it's not based on science. And I can tell you that they weren't looking at the gut microbiome in 1897 when they developed cornflakes.
Yeah.
It had nothing to do with it.
Gout. Gout is something that it's difficult to find a straight answer about what's going on with gout. Some people will say it's tomatoes, others will say it's beer. I don't tend to believe either of those, but in your talks, there does seem to be some pretty solid biochemistry showing that excess uric acid is a result of this overconsumption of refined foods. So I was just wondering if you could just basically give us a broad understanding about what is precipitating gout flare-ups.
Well, it's sort of been traditionally said, okay, it's the rich person's diet, and it's been demonized as too much meat and alcohol. And I said meat rather than red meat. I gave a talk to the meat. Here's my conflict of interest. I'm an unpaid meat and red meat ambassador for Meat and Livestock Australia. Okay, they sort of ended up nominating me, and I don't know what it means, but I should declare that conflict of interest. And a part of one of the talks I gave to them was, why do we call red meat red meat? Why don't we just call it meat? It's being discriminated. Why isn't it white meat, green meat, orange meat, red meat? Once it's cooked, it's brown meat, And, pork's actually called a red meat, even though it's a white meat. So when you start delving into that, you actually find out, guess what? This is actually, and looking at the biochemistry of different meats, they're actually all fairly similar. They just come in different colours and come from different animals. And actually human meat's actually not a hell of a lot different to animal meats, because we're just animals at the end of the day. So I always sort of fascinated why red meat's become demonised, because, and again, it's got cultural intonations, and it comes back to religious ideology, and it's just a fascinating journey going down that pathway. So therefore, if you look at society on the whole and look at data over the last 40 years, we've decreased our red meat consumption. That's the data we've got. Whether or not we've increased our chicken consumption, but when you look at data, and they have classified it as red meat, even though we've decreased our meat consumption, we've decreased our alcohol consumption. We still have as a society, we probably have too much, more in pandemics and shutdowns, but yet there's been a doubling of gout in the world and in Western society in the last 10 years. So the graphs are there. We're decreasing our intake of the traditional foods associated with it. But we've got an increasing problem. And again, I come back to 2010 and that Look Taffy paper. One of the byproducts of fructose metabolism is uric acid. I can remember my assistant, who's a GP, he said, "Oh, you're absolutely full of nonsense," when I said, no, fructose is actually a byproduct of, uric acid is a byproduct of fructose. But there it is. My textbooks just went fructose 6-phosphate and didn't say anything else. That was it. That literally finished there. And I realised my textbooks are old, but that's exactly what happened. So then I went, then the modern, it goes down several pathways, but effectively uric acid is a byproduct. And then when you find out that glucose via the polyol pathway, 30% of it gets converted to fructose, this is where I talk about the runaway train. So we're having these carbohydrate-laden diets. We're having insulin resistance. We've got people with obesity, pre-diabetes and diabetes, increasing numbers. 30% of the population are pre-diabetic, possibly more if we test it. We've got at least half to 2/3 of the population now who are overweight and obese, depending on which age group. We start saying, okay, that group now are going to be 30% of the glucose that they eat, 30% of the bread, 30% pasta, rice, below ground vegetables is now getting converted into fructose. And I think this is the runaway train. I use that term because it's not just, people aren't just going out and eating more and more sugar, and arguably sugar consumption's come down a little bit. It's one of the arguments of the sugar-sweetened beverage industry to say, actually, we're not the cause of obesity because, look, sugar consumption is down and soft drink consumption is down, but some of that data is quite twisted around, which is not surprising. Have you caught up with Rory Robertson?
No.
Oh, Rory just takes that apart in great detail. He works for the Reserve Bank as an economist, but he is a real bee in his bonnet about the fact that where all that data has come from. And Rory's work, again, just because that's the big article which keeps getting quoted, sugar consumption's down. I went and did a sugar beverage course, a beverage manufacturing course with someone from the sugar industry. I didn't identify who I was, but I actually went to it. And they had someone there who got up and just quoted the same literature. Sugar's not the problem. Sugar's not the problem. Well, in fact, sugar is the problem, but there may be a portion of it which actually may be related to this excessive carbohydrate consumption that we have. We've got dietary guidelines that say that our diet should be 50% carbohydrate, 50 to 60%, but let's say about 50%. Well, I've just given a talk about the fact that we actually could probably get by with zero carbohydrate consumption. So where did 50% come from? Because it certainly wasn't part of our ancestral diet. Again, seasonal availability, not on a daily basis. It might have been for the few weeks when fruit ripened in summer or when we were able to get to the root vegetables by digging up a tree. And when was the last time you actually went and dug up potatoes for a meal? Most people go to the shops. So if you go to the same thing with honey. When was the last time you climbed a tree in the wild to get honey out of the hive? it's just, it's a big difference for the amount of energy expenditure to actually the caloric benefit. So our excessive 50-60% of our carbohydrate in the diet on a population that's already overweight and obese means that is a massive fructose load, which is now travelling down that uric acid pathway. Uric acid has a direct effect when the tissue levels go up of causing gout. Essentially, gout's the precipitation of those uric acid crystals in the tissue. So, and one of the problems with it, uric acid actually isn't measured that well in the bloodstream. So you might have a normal uric acid level in the bloodstream, but your tissue levels are high. Nobody in their right mind is going to have a biopsy to work out the uric acid levels in the tissue. Ken Sakaris, who's a professor of Melbourne pathology, when you talk to him about uric acid, he actually thinks that we've set the blood level artificially high, because it's a bit like vitamin D levels, where if you start testing people, you find out that 70% of people are actually vitamin D deficient. So what did they do? They lowered the normal range so that 70% of people aren't abnormal. So again, he actually thinks the same thing with uric acid. We could probably drop 0.1 off that because he thinks, sorry, we could add 0.1 to it. So that person who has, I've always seen, who clinically has gout, and they've got a uric acid level that's the higher range of normal. I say you've still got gout in my mind, because I think that that number's been artificially raised because 70% of the population are overweight and obese and have got an elevated tissue uric acid level. Quite common at arthroscopy to see uric acid crystals within the knee, within the ankle. So most people think about it's going to affect the big toe. It's one of the thoughts behind back pain, that people have got elevated uric acid levels in the tissue. I'm not into doing multiple blood tests or tissue tests on patients. I said, look, have a look at the amount of processed food in your diet. Here's my argument: eat fresh, local, seasonal, whole food, blah, 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 and see how you feel. And now I know about the inflammatory effect of insulin on osteoarthritis. I've got so many people who actually lose their joint pain before they lose weight. I said, that's fascinating. End-stage osteoarthritis, bare bone in their knees, who actually are ready for a knee replacement. I say, well, look, just go this low-carb stuff for a while, drop your insulin levels and see how, occasionally I'll test an insulin level on someone who's interested in it. I said, because there's no cost in actually getting rid of stuff out of your pantry. Just go and eat some whole food for a couple of weeks and then see how your arthritis feels, because that's infinitely cheaper than me operating on you. As it turned out, I was, every week I'd be talking people out of operations. And I know that sounds strange as a surgeon, but we don't have a system set up to talk people out of operations. We've got a system. I mean, I get remunerated by operating on people, not by not operating on people. And one of the theories I've had is we should actually have a reward system for surgeons who don't do any operating. If I can avoid you having your knee replacement for 5 years, then how about you give me 10% of the fee? I don't know. I'm making up numbers, but we don't have a health system. We have a sickness industry. Everything's dependent on just keeping things ticking over. It's quicker and easier to write a prescription out than it is to talk to people about lifestyle changes. There's no money or very little money in supporting people for dietary change. And that's exactly what they need. They support, Belinda calls it SAM, support, accountability, motivation. You need to keep people on track. You need to keep knocking down those fires that get lit up because of the disinformation that's out there. Keto's bad, low carb's bad. You need glucose to keep your brain functioning. These things are just made up. They're literally generational non-science. And so, but the system's not set up for that. And as a result, we're stuck in exactly where we are. We're on this spiraling health crisis that's going down. And if you're waiting for the government to change their mind about this and say, sorry, we got that one wrong, that's not going to happen. So the individual can make that decision today. They can do that this afternoon. You can just say, actually, I'm going to go along and I'm going to have some meat and veg this afternoon. I'm not a carnivore. I still have a bit of veg, but I'm more carnivore than I used to be. But I also eat more offal than I used to.
Yeah, absolutely. And I think
I've got to deal with it.
Yeah, well, I think if there's one message that we can get out, it's support your local farmer who's doing responsible regenerative pastured animals.
And they're there if you look for them.
Yeah.
And they're now putting their flag up. And that's about supporting that individual, because that's the exit strategy. And we take the food miles out of the equation. We're looking at those people are the ones looking after the soil. If you've seen my talks, I've got an environmental hat that I wear as well.
Yeah.
I think the term I use is like the health of the people is determined by the health of the food of the food is determined by the health of the soil of the soil is determined by what we do to it.
Yeah, absolutely. I think that would be a great way to finish up here. And I think there's no point waiting for the government to tell us what's right. And I hope that podcasts like this are really helping you get your message out there so that people can make their own decisions about how to be healthy. I think we are very grateful for the work that you've done and the fact that you've put your neck on the line to get this information out there.
It's still there. I'm fairly thick-skinned. One of my colleagues called me Teflon at some point in time. A whole lot of stuff gets thrown at me, but not a lot sticks. So.
Yeah. So I think a lot of people are very grateful, myself included. So thanks for all the work that you've done.
Cameron, look, what Belinda and I have done over the last several years, 12 years or whatever, we actually think it's just the right thing to do.
Yeah.
And it's made a difference to our lives, it's made a difference to our families' lives, and it has actually helped people. And I often use the term that that actually gives joy back in medicine. When you actually, our diabetes educator, after a couple of decades of giving standard diabetes advice, was unhappy, and we found her skipping down the corridor one day with joy. And we went, wow. And because all she'd done is give people the right advice of turning the diabetes around. That's all. Why don't we just leave on wow? Okay.
That would be great. Thanks so much.
Right. Okay. Right. Good luck, mate. Thank you.
See ya. Thank you so much for listening. I really hope you enjoyed our conversation as much as I did. I've put all the links to Gary's work in the episode notes if you'd like to learn more about him. He also has many hours of insightful videos on YouTube. If you'd like to keep up with my work, feel free to follow me on social media platforms using @RicciFlowNutrition. Thanks again for listening. Take care, everyone.